Okay, when you're factoring a quadratic, but there are only two terms, there's this special relationship that you have to look for. What you want to look for first is there a subtraction sign between the two terms? And is each term a perfect square? So if you were to take the square root of this, well, 9's a perfect square. N squared is a perfect square. Can you take the square root of 4? Yes, you can take the square root of 4. So if those two things exist, the two things are each of those a perfect square, and is there a subtract sign? You have what's called this special relationship called the difference of squares. What's nice about this is that it takes about 2 seconds to factor. What you need to do is, if you've got something squared, subtract something else squared, when you factor it, you'll be using the conjugates. And I'll show you what I mean. You take the square root of each of those terms, and you put the square root there, the square root there. Of the second term, you put the square root, and in the parentheses, one of the parentheses gets a subtract, and one gets an add. So for example, the square root of 9n squared would be 3n. So in parentheses, a 3n would be the first term in both of those. Well, the square root of 4, let me change that color, is 2. So you'd put a 2 in each of those, and then one would get subtract, one would get add. And that part, it doesn't really matter which order you put that. So you could put a plus, and you could put a subtract, or you could put subtract, and then you could put the add. Because you're multiplying, and it doesn't matter if you multiply 4 times 5, that means the same thing as 5 times 4. So the factors, it doesn't matter which order you put them in. And then, voila, that's all there is to it. So the square root of the first term, square root of the second term, and then one's a subtract, one's an add. That's it.